students, I hope all of you are doing good. Let's start today's chapter, operations on whole numbers. We are familiar with the four fundamental operations: addition, subtraction, multiplication and division on whole numbers. In this chapter, we will learn about the properties of these operations on whole numbers which enable us to make calculations easier and faster. Let us consider a few examples. We want to add two whole numbers, 25 and 46. These are natural numbers too. On adding the two, we get 71, which is a whole number. Also, 3879 plus 3107 is equals to what? 6986. Similar shall be our experience if we add any two whole numbers. Thus, we have one whole number plus another whole number is equals to a third whole number, right? So, generalizing this fact, we can say that if any two whole numbers A and B are added, we get a number C, which too is a whole number. Thus, A plus B is equals to C. However, if A or B equals to 0, then A plus B is what? C. If A plus B is what? If A is 0, then 0 plus B is what? B. And A plus B is A if B is 0. We will put the value of B as 0, so A plus 0 is A, right? Now, properties of whole number. Property number 1. If A and B are any two whole numbers, then A plus B is equals to C. C is the sum of A and B, which is also a whole number, right? In other words, the sum of any two whole numbers is a whole number, or whole numbers are closed for addition. This property is called closure property. Let us verify this with the examples. See, one whole number, this is another, and sum of A plus B is, that is 8 plus 7 is 15, which is another whole number. So, whether the sum is a whole number? Of course, right? Property 2. If A and B are any two whole numbers, then A plus B is equals to B plus A, means 1 plus 2 is equals to 2 plus 1, because 1 plus 2 is 3 and 2 plus 1 is also 3, right? That is, the sum of two whole numbers remains the same even if the order of whole numbers or addend is changed. Verification. You can verify here. 8 plus 7 is 15 and 7 plus 8 is also 15. Okay. Now, property 3. If A is any whole number, then A plus 0 is equals to A is equals to 0 plus A. That is the sum of any whole number, and 0 is the number itself. The 0 is the only whole number that doesn't change the value of the number it is added to. The whole number 0 is called the additive identity or identity element for addition. Property 4. If A, B and C are any three whole numbers, then A plus B plus C is equals to A plus B plus C. That is, addition of whole numbers is associative. In order to prove the associative property, we consider the following table. See, A, B and C. Value of A is 8, value of B is 12 and value of C is what? 21. Okay, now A plus B plus C is 8 plus 12 plus 21. 8 plus 12 is 20. 20 plus 21 is 41. Now, A plus B plus C. A is 8 plus 12 plus 21, right? So, what will we get? 12 plus 29 is what? 33, and 8 plus 33 is 41. See, in both the cases, the sum is same, right? Example, find the sum of these three numbers. Okay, so what will you do here? Have a look. 847 plus 253 plus 488. First, we will add these two. 847 plus 253 in brackets 3 plus 488. So, 1100 plus 488 is equals to 1588, right? Now, let's do exercise 2.1. Fill in the blanks to make each of the following a true statement. 395 plus 674 is equals to 674 plus, which number will come here? This number, okay, that is 395, right? Properties of subtraction. We know that in addition we combine objects together, while in subtraction the objects are taken away. Hence we say that operations of addition and subtraction are inverse of each other. We shall consider the properties of subtraction of whole numbers. They are given below. Property 1. If A and B are two whole numbers such that A is greater than B or A is equals to B, then A minus B is a whole number. However, if A is less than B, then subtraction A minus B is not possible in whole numbers, right? Let us verify this with the help of given table. Okay. One whole number is given, which is 9, another is 8. This is A, this is B. A minus B is 9 minus 8 is equals to 1. Okay. And if it is asked if A minus B is a whole number, of course. Okay. But here in this case 155 and B we have 180. 155 minus 180 is equals to what? The answer will come in negative and it is not a whole number. That is why it is written no over here, right? Property 2. If A and B are two whole numbers, then in general A minus B is not equal. Okay, A minus B is not equal to B minus A. For example, 3 minus 2 is not equals to 2 minus 3, right? Consider an example 13 minus 7. See, 13 minus 7 is 6, but 7 minus 13 is not possible, okay? Thus, if A is greater than B, A minus B is a whole number and B minus A is not possible. Therefore, A minus B is not equals to B minus A. Property 3. If A is a whole number other than 0, then A minus 0 is what? A, but 0 minus 8 is not possible, okay? Property 4. The subtraction of whole numbers is not associative. Thus, if A, B and C are three whole numbers, then in general, A minus B minus C is not equals to A minus B minus C, okay? Verification, we can verify. A is given 10, B is given 9 and C is given 8, okay? So, A is 10 minus B minus 8. 10 minus 9 minus 8 is 1. So, the answer is 9. Okay. Now, A minus B minus C. A is 10 minus 9 minus 8. 10 minus 9 is 1 and 1 minus 8 is what? Minus 7. Okay. So, we have verified this. Okay. Now, example 1. Perform subtraction and check your answer by corresponding additions. Okay, first you will subtract and then you will check your answer. How are you going to check this? You will add these two numbers, okay, and then after adding you will get this number, okay. Exercise 2.2. Do the following subtraction and check your answer by corresponding additions. Okay, students, you will do like this, like 15 minus 10 is what? 5. And then you will check your answer. You will add these two numbers. 10 plus 5 is equals to 15. Okay. That means your answer is correct. So, similarly, you will subtract these numbers and then you will check your answer. Okay. Now, properties of multiplication. In previous classes, we have learned that multiplication is repeated addition, right? When we need to add numbers many times, we multiply it by the number equal to the number of times it is added. For example, if we have to add 7 5 times, we add 7 plus 7 plus 7 plus 7 plus 7 is equals to 35. This can be written as 7 into 5 is equals to 35. In this section, we shall consider the various properties of multiplication of whole numbers, as these would help us in finding products of even larger numbers with ease and convenience. Okay. Number 1, closure property of multiplication. If A and B are any two whole numbers, then A into B is also a whole number. Means 2 into 3 is 6. This is A, this is B, this is C. Means whenever we multiply two whole numbers, the product we get is also a whole number. Okay. Now, let us verify with the help of whole numbers as shown in the following tables. Okay. As you can see here, by multiplying two whole numbers, we get the product as a whole number. Okay, so we find that the product is always a whole number. Number 2, commutative property of multiplication. If a and b are any two whole numbers, then a into b is equals to b into a. Means 3 into 4 is equals to 4 into 3. 3 into 4 is 12. 4 into 3 is also 12. So let us verify this property by taking a few pairs of whole numbers as shown in the table given below. Okay, two numbers are given. 8 into 9 is 72 and 9 into 8 is equals to 72. Okay. Now number 3, multiplicative property of 0. If a is any whole number, then a into 0 is 0 and 0 into a is equals to 0. This product of any whole number and 0 is always 0. Okay, whenever we multiply any number with 0, we get the product of 0. Number 4, existence of multiplicative identity. If a is any whole number, then a into 1 is equals to a is equals to 1 into a. Thus the product of any whole number and 1 is the number itself. For example, 27 into 1 is equals to 27. 1 into 27 is equals to 27. Okay. We shall verify with the help of following table. You can see here 15 into 1 is 15, 1 into 15 is 15. Okay. Thus in each case, a into 1 is equals to 1 into a is equals to a. The number 1 is called the multiplicative identity or the identity element for multiplication of whole numbers, right? Number 5, associative property of multiplication. If a, b and c are any three whole numbers, then a into b into c, okay, a into b into c is equals to a into b into c. Thus multiplication of whole numbers is associative. That is, the product of three whole numbers doesn't change by changing their arrangements. We can verify this by taking any three whole numbers and find the values of expressions a into b in bracket into c and then a into b into c in bracket as shown in the table given below. Okay, you can verify here from here, right? So thus we see that when we multiply whole numbers, even if we change the arrangement of the numbers, the product remains the same. Number 6, distributive property of multiplication over addition. If a, b and c are any three whole numbers, then a into b plus c is what? A into b plus a into c. Okay. In other words, the multiplication of whole numbers distributes over the addition. We shall verify the truth of this property as shown in the table. Okay, here a is 4, b is 5 and c is 6. Okay, now what will we do? First a into b plus c, that is 4 into 5 plus 6. 4 into 11 is 44. Now a into b, that is 4 into 5 plus a into c, 4 into 6, 20 plus 24 and the sum is 44. Hence verified. Okay. So we see that expressions a into b plus c and a into b plus a into c are equal in each case. Note, if a, b, c are whole numbers such that b is greater than c, then a into b minus c is equals to a into b minus a into c. For example, a, b and c, value of these are given. Okay, then we will find that this side is equals to this side. Okay, now let's do example 1. Find the following products. Okay, how will you do it? Four into 25 into 1825. First you will multiply these two numbers. Okay, into 1825. 100 into 1825. Now let's multiply. We will add two zeros here, right? Multiplication of numbers containing two or more digits. Distributive property of multiplication over addition of whole numbers help us to understand better the process of multiplying numbers containing two or more digits. Let us consider some examples. Okay. So example 1, multiply 67 by 43. Okay, so we will write it like 43, 67 we can write it as 40 plus 3. Okay, 67 into 40 plus 67 into 3. Okay, so what will you get here? Plus 67 into 3 is 201, and after adding you will get 2881. Okay, exercise 2.3, fill in the blanks to make the following statement true. If a number is multiplied by 1, what we get? We get the same number. If a number is multiplied by 0, we get the product as 0. Okay, division. We have learned in earlier classes to divide a whole number by another whole number. In this section, we shall consider division as a repeated subtraction and also as inverse of multiplication. Suppose we have to divide 35 by 7. 35 divided by 7 is equals to 5. Consider 35. To divide 35 by 7, we subtract 7 repeatedly from 35 till we get 0. See, 35 minus 7 is what? 28. 28 minus 7 is what? 21. 21 minus 7 is what? 14. 14 minus 7 is 7, and 7 minus 7 is 0. How many times we have subtracted 7? 1, 2, 3, 4 and 5. That is why the answer is 5. Okay. We find that when 7 is repeatedly subtracted 5 times, we arrive at 0. Okay. Division as the inverse of multiplication. Let us consider the following examples. 28 divided by 7 is equals to 4, and 4 into 7 is equals to 28. Similarly, 42 divided by 6 is equals to 7, since 6 into 7 is equals to 42. Thus, generalizing, we can say that if A and B are two whole numbers, A divided by B is equals to C, implies that A is equals to B into C. Symbolically, we write A by B is equals to C, or A is equals to BC, that is B into C. So, before considering the properties of division, we need to learn the following definitions. And I am sure you know about all these terms. Okay. Dividend, the number which is to be divided is called dividend. Divisor, the number by which the dividend is divided is called the divisor. For example, if you are dividing 35 by 5, this is 35 by 7. This is what? Dividend. This is what? Divisor. Okay. 7 5s are 35. Okay. Now, quotient. The number of times the divisor is contained in the dividend is called quotient. This is quotient. And remainder, the number which is left over after division is called the remainder. This is the remainder. Okay. So, thus, if A is divided by B and we get Q as quotient and R as remainder, then we have A is equals to BQ plus R. Thus, the division algorithm can be stated as dividend is equals to divisor into quotient plus remainder. Verification. Consider division of 154 by 9. By actual division we get, okay, let's do the division. 154 divided by 9, okay. 9 ones are 9, 6, 9 sevens are 63, okay. So, 154 is what? You can see remainder, this is quotient, this is a remainder, right? 154 is what? 9 into 17 plus 1. That is 153 plus 1 is 154. That is A is equals to BQ plus R. Okay. Now, properties of division. Property 1. If A and B are whole numbers, then A divided by B may or may not be a whole number. Okay. This property 1 of addition and multiplication does not hold for division, right? Let us consider the following two examples. For example, 25 divided by 5 is what? We will subtract 5 first time, then second time, third, fourth and fifth, and then we'll get 5. 25 divided by 5 is 5. That is a whole number. But if you divide 17 by 3, we will not get a whole number. Okay. So, property 2, division by 0 is a meaningless operation. Means you cannot divide any number by 0. As division is a repeated subtraction, we have, if you subtract 0 from 10, what will you get? 10. Again subtract 0, you will get it. So this is meaningless. Means you cannot divide any number with 0 by 0. Okay. Property 3. If a is any whole number, then a divided by 1 is equals to 1. In other words, any whole number divided by 1 gives the quotient as the number itself. Okay. For example, 6 divided by 1 is equals to 6. Okay. And 1 into 6 is 6. 50 divided by 1 is equals to 50, and 50 into 1 is 50. Right. Property 4. If a is any whole number other than 0, then a divided by a is equals to 1. Means if same number is divided by same number, we get the quotient as 1. For example, 15 divided by 15 is equals to 1, and you can also verify 15 into 1 is 50. Okay. Property 5. 0 divided by any other whole number other than 0 gives the quotient as 0. In other words, if a is a whole number other than 0, then 0 divided by a is equals to 0. So verification, 0 into 8 is equals to 0. Means if you divide 0 by 8, you will get a 0. Okay. Property 6. Let a, b and c be whole numbers, then a divided by b is equals to c, then a is equals to b into c, right? And if a divided by c is equals to b, then b into c is equals to a. Okay. That is, as operation of addition and subtraction are inverse of each other, the operation of multiplication and division are inverse of each other. Okay. Now consider this example. 4 into 2 is equals to 8. 8 divided by 2 is equals to 4. 12 divided by 3 is 4, and 3 into 4 is 12. Okay. Thus in general, if a divided by b is equals to c, b into c is equals to 8. Okay. Now look at the following example, multiplication fact, division fact. Okay. So multiplication fact is what? 2 into 8 is equals to 16. This is multiplication fact. Now division fact, 16 divided by 8 is equals to 2. Okay. And 16 divided by 2 is what? Is 8. Okay. In general, b into c is equals to a, then a divided by b is equals to c, and a divided by c is equals to b. Thus we know that for two distinct non-zero whole numbers, for every multiplication fact we have two division facts. Okay. Example 1. Divide 48,073 by 275 and check the result by division algorithm. Okay. So here when you divide, you will get 174 quotient, 223 remainder, and then you have to check the answer. So checking answer, what will you do? We will multiply quotient and divisor, then we'll add remainder. Okay. And the answer gives the dividend. That means our answer is correct. Okay. Exercise 2.4. Divide and find the quotient and remainder. 6,727 divided by 58. Okay. We will take first two numbers. 58 ones are 58. 7 minus 8. We cannot divide, subtract 8 from 7. So we'll take carry from here. 17 minus 8 is what? 9. Then 2. Again 50 ones are 58. 12 minus 8 is 4, and 8 minus 5 is what? 3. Then 7. Okay. Now 58 5s are what? 5 8s are 40, 4 carry, 5 5s are 25 plus 4 29. Okay. 7 minus 0 is 7, and 14 minus 9 is 5. That is 57. This is quotient and this is remainder. Okay students, now you will do practice of the remaining questions. Learning outcomes. The smallest whole number is 0. The smallest natural number is 1. Number 2, the successor of a natural number or a whole number is 1 more than number. 3, the natural number 1 and the whole number 0 have no predecessors. The predecessor of a natural number except 1 or a whole number except 0 is 1 less than the number. If a, b, c, etc. whole numbers, then a plus b is a whole number, a into b is a whole number, a minus b may or may not be a whole number. Okay. A divided by b may or may not be a whole number. A plus b is equals to b plus a A into B is equals to B into A. A minus B is not equals to B minus A if A and B are unequal. A divided by B is not equals to B divided by A if A and B are unequal. A divided by B is equals to B divided by A if and only A is equals to B. A plus B in bracket plus C is equals to A plus B plus C. 14 is A into, then in bracket B into C is equals to A into B into C. Then 15, okay. So we all learned about all these properties and we verified also, okay. 21, in general, A minus B in bracket minus C is not equals to A minus then B minus C in bracket. 22, in general, A divided by B divided by C is not equals to A divided by B divided by C in bracket. 23, if A is dividend, B is divisor, Q is quotient and R is remainder, then A is equals to BQ plus R, that is division algorithm. Okay students, I hope you have understood this chapter. Now keep doing practice of this chapter.